Right. So we were talking about the AC system. So in which we have two important things. So one is the magnitude, and another is the phase. Another is the phase. So usually it look like this. So for example, if I have a voltage of Vm sine or cos, it's your wish. So let me take the cosine function. Cos omega t plus theta. So in this, our major concern is on the magnitude and the phase of the system, which is phase difference. So once we know these two information, it is easy to go with this kind of representation to a short form of representation which we call as a phasor, which is equal to Vm by root 2 at an angle of theta. So this we call as a phasor representation, which is very important representation for us. And in generally, I told you in the last session that the phasor representation can be expressed in three forms. So in generally as like this, or at an angle of theta is what the polar form, which can also be represented as r e power j theta, which can also be represented in another form as r cos theta plus r or j or sin theta. So in either of the form we can represent this phasor representation. Okay, these three forms are important for our study. Or at an angle theta form. Try to observe here it is r at an angle of theta form. And it can also be represented as r e power j theta or r cos theta plus r sin theta. So one should understand these three forms. What are its? One is polar form, this last one is rectangle form, this is in the exponential form. Okay, right. So now most of the times we will be dealing these kind of numbers which are simply complex numbers which has magnitude and angle, or which has real part and imaginary part. So in order to deal these things, so we will mostly use the calculator. So let us see how to deal these complex numbers in the calc. So all of you, I hope that you have this kind of calc what I am having. So if not, so you can learn on your own, no issue. And first try to keep, so mostly try to see that your calc is in degree mode. So keep the calc keep in degree mode. So where you will see D symbol somewhere on your calculator display. So where I could see is that here it is not so clear, but you can see there some degree. So after that, so all of you press mode button, this one. So once you press the mode button, then you could see this display. So check it whether you could see this display or not. So in which after pressing this, so choose number 2, which represents CMPLX complex. CMPLX complex. So once you choose this, now you are in a position to type any number in the complex form. So that I will show here. That for example, if I have certain number something like 10 at an angle of 20, which is in polar form, basically this can also be treated as a complex number which has magnitude and phase. So whichever has magnitude and phase can be equivalently called as a complex number. Why? Because this is in the polar form, we can write this into rectangle form which look like a plus jb form. A plus jb form, which is a complex number. So now we can say that this 10 at an angle of 20 is a complex number. We would like to read this number in the calc. How can we enter? Is that first you type 10 10, then see that after 10 you type shift this shift button, then followed with some angle symbol will be there. So I think yes, it's there. Here it is some angle symbol. Let me highlight that with some color. See here, here some angle symbol is there. This corresponding button you press it. So what is that? Is shift, then this angle symbol is there. That button you press. As a result, what I'll get is that on the Calc I'll get as like this. So with these steps, I'll get 10 at an angle. Then after that you enter simply 20, some number 20. So all of you try this. So then after entering this, after entering 20, just press equal. You should see the result over here. 10 at an angle of 20. So just confirm me whether you got this value 10 at an angle 20 or not. Yes, please.
So we have another calculus, sir, not this type, sir.
Yeah, so those who have different calculus, so we deal it separately. So as of now, those who have these things, so just try to follow. Okay.
Yes, yes sir.
9.396 అలా వచ్చింది సార్.
Okay, so I'll tell you. So some may got, I hope some of you got this 10 at an angle of 20 result on the screen as it is like this. Okay, I believe that some of you got this thing. Those who did not got this, no issue. So I'll show that how to get this value. Okay. So after this, so try to see that if your result is 10 at an angle 20, no issue. Even if it is different value, so let us for the time being assume that you are getting some result. It doesn't matter. Now next what we do is that use shift button and setup. So first press shift in the next step, shift, then setup button. See here is the shift. This is one, followed with press this corresponding button, setup button. As a result, you will get this display. So I hope those who are following, so I hope you got these things, this display, that one is math IO, 2 is line IO, etc. This kind of display. Then after getting this display, use this replay button, press the downward arrow. This is what the downward arrow on replay button, this is replay button, in which press this downward arrow. Then as a result, you will get in the next display, one is AB by C, 2 is D by C, 3 is CM PLX. So could you see this? Once you press, as a result of this shift setup, then downward arrow, what you get is this display you will get, in which the important thing is 3 CMPLX means complex. Now choose 3, just press 3. As a result, you will get your result to be in this form. Actually, above this you will see two things. So you will see two things. I missed one more screenshot here. So what you will get is that, just let me write here. Once you press 3, what you will get is that, so complex result question mark, complex result question mark, as like this. So one is A plus BI means rectangle form. So 2 is R at an angle theta form, means polar form. Which result you want, which form you want. So depends on your requirement, you choose that, either 1 or 2. So I'll be choosing 1. So if I'll choose 1, my result look like, so this like how much is this, 9 point something, I don't know. So just let me see, 10 at an angle of 20. So then my result is 9.39. So plus 3.42 J something. So if you need the result to be in A plus BI form, choose one. If you need result to be r at an angle theta form, choose 2. So preferably, I will keep my calc result always to be in r at an angle theta form. So then choose 2 if you want result to be in this r at an angle theta form. So I will be choosing 2 as of now. So as a result of that, my answer look like 10 at an angle of 20 form. 10 at an angle of 20 form. All of you got this? So finally, once you choose 2, is your result on the display should look like this. 10 at an angle 20. Okay. So with these instructions, you can explore on these calculating the complex numbers. Then let us see how can we use our calc for calculating various kind of additions, subtractions, etc. Okay. So just let me show some calculations out of this. These are I1, I2. So the objective is what is I1 of t plus I2 of t. So remember that if something is in sine and if you need the result to be in sine, you no need to convert sine into cosine form. So keep as it is in the sine and express in phasor form. But if somebody asked that just find the phasor notation of I1, phasor notation of I2, then you have to convert this sine into cosine form. And here depends on the result. What you need? Do you need the phasor representation or simply addition? So based on that you can make conversion or not. So that is left to you. So let us take here. So I can make I1 bar as like this. So 10 root 2 by root 2, that is 10 at an angle of 45. This is what the I1 corresponding current in phasor form. What about I2? I2 bar is equal to 5 root 2 by root 2. So which is equal to 5 at an angle of minus 45. See that I haven't converted these into cosine. Why? Because my aim is not getting the phasor representation. My aim is getting simply addition of these two currents. So let us see how can we do it. Now what I will do is that my aim is addition. So I will add the phasors as like this. I1 phasor plus I2 phasor, which is equal to 10 at an angle of 45 plus 5 at an angle of minus 45. One thing you can do is that you convert this polar form into rectangle form and add it. So but as because these scientific calculators, so now I can type directly 10 at an angle of 45, then plus 5 at an angle of minus 45 directly. So just all of you try this. So I am just doing these things. So if you want, you can open one bracket so that to avoid any kind of mistake. So just 10 shift angle symbol 45 and close the bracket, and then 5 shift angle symbol minus 45, then close the bracket and press enter. Then if your calc is in like a plus bi form, so you will get something like this: 15 root 2 by 2 plus 5 root 2 by 2 I means it is equivalent to j. Now if you use these things, that press shift, then then set up, then what you will get is one math IO etc. Then after that use replay button, down arrow, then you will get 3 CMPLX complex. Then if you choose 3, you will see complex result to be in A plus BI or 2 is r at an angle theta. I am choosing r at an angle theta. So I am choosing 2. So as a result, my result is 5 root 5 at an angle of 18.4349. 18.4349. So if you want, this 5 root 5 will give 11.18 at an angle of 18.4349 degrees. So this is what I1 plus I2 result in complex form. So but I need to convert back this result into like normal form, like in time function. So I can say from here, very important thing, I1 of t plus I2 of t in time function is equal to just reverse conversion. Here we did time to phasor, now phasor to time. That is 11.18 into root 2. This is what the peak value. We know that Vrms is equal to, or Irms is equal to, whatever it may be. Irms is equal to Im by root 2. What do I need here? Peak value. So how I will get? Multiply with root 2 by RMS value. So you will get peak value here. So which function was there already initially? Sine function was there. So I will be using sine. How much is the omega? 2t. Then how much is the angle now? When we add up 2 together, it is 18.4349 degrees. So this is what I1 plus I2 answer at the end. So as because I am not doing complete phasor representation of I1 plus I2, just I need the result to be like additive in this way. Ultimately I need this, we call this as time domain function. This as time domain, as because you could see this, the current is expressed as a function of time, small t. If small t is not there, we say that as a frequency domain or phasor domain. So this is time domain equivalent. So sum of the currents. Now if somebody asks, what is I1 into I2? Let us say next question. Next question is that, what is I1 of t into I2 of t? What we will do? Again take the phasors to do this, then at the end you convert back to time domain. How much is I1? I will say I1 bar into I2 bar, means phasors product. So 10 at an angle of 45 into, so 5 at an angle of minus 45. So the product is so simple when it is in polar form. Just multiply the amplitudes. 10 into 5 is 50. Then add the angles. 45 minus 45, 0. This is what I1 bar into I2 bar. But what I need ultimately is I1 of t into I2 of t. So what we will do? We will convert this phasor into time domain function. How? 50 into root 2. Then already existing thing is sine. Omega is also known, 2t. Now how much is the angle? 0 angle, plus 0 degrees. This is what the amperes, that is I1 into I2, product of the currents. So in this way, so these additions, division, if you want, you can take up one more step ahead. So division also we can do. If we need I1 of t divided by I2 of t. So how could we do this? So in order to this, so what we will do is that we will divide the phasors first. I1 phasor by I2 phasor. Then how much is the I1? 10 at an angle 45 divided by 5 at an angle minus 45. So when we take this division operation, magnitudes can be divided directly. So 10 by 5 is 2. Angles are subtracted, that is 45 minus of minus 45. So it gives 90. So once you get the division in phasor form, now try to get back the division form in time domain by converting this phasor into time function, that is 2 root 2. What is the existing function? Sine. How much is the angular frequency? 2t. Now what will be the angle? 90 degrees. So this is what I1 by I2. Just think of that without these phasor calculations. If I will do directly by the raw given things as like this. So 10 root 2 sine 2t plus 45 into 5 root 2 sine 2t minus 45. How much time does it take to multiply these two quantities and to get the result into this form? Like 50 root 2 sine 2t plus 0 form. It takes lot of time. It needs a lot of mathematical computation. So to avoid all those things, we will go with this phasor representation. See how simply we got I1 into I2 and I1 by I2 and I1 plus I2. So this addition, division, multiplication can be simplified for the sinusoidal functions enormously by using this phasor representation. This is one of the major advantage of the phasor representation. So let me take one example. So for this phasor representation also as like this. So simplify the expression into simple form. So let us say 4 at an angle of 20 plus 4 minus 20j by uh, 6 plus 8j plus 10 e power j 20. Just simplify this. Various forms are there. If you want, yeah, this is enough, no issue. Simplify this into single phasor form, like r at an angle theta form. So you can directly type in Calc, but try to observe, you will not get any of this form in the calculator. So try to observe what is the format of this. This is in exponential form. We know that r e power j theta is equal to r at an angle theta. So this you should observe, that exponential representation and polar representation. So now I can say directly 4 at an angle 20. So you can take as it is 4 minus 20 j divided by 6 plus 8j. This thing I will write as 10 at an angle of 20. Now you can use your calculator and type all these expressions directly in the Calc as like this. So if you want, you can use the brackets so that you will not have any problem in addition multiplication of the magnitudes and angles. So I will be typing 4 at an angle of 20 plus, so 4 minus 20i. So you will get I symbol, just to see like above 8 ENG symbol is there, ENG button. There you will get in pink color I. Once calculator is in complex mode, you will get directly that I. If Calc is not in complex mode, you will not get the I symbol. Once you type I, you will not get it. So your Calc should be in complex mode initially. Clear? So 4 minus 20 I divided by 6 plus 8i. I means it is equivalent to j. So next is plus 10 at an angle of 20. So these are the expressions which I have three different terms. So how much I am getting is 12.24 at an angle of 15.48 degrees, something approximately 486 something is there. So if you want the result to be in rectangle form, you can do same thing that what I told you previously. So 11.79 plus 3.268 j or I, so these are the complex numbers, dealing how to deal the complex numbers in the calculator.